Hi children, welcome to our session. Today we are going to discuss about the topics which we already covered. It's a revision, okay? Let's start. Logic gates. A logic circuit is the one which takes one or more inputs and generates an output. Logic gates use the binary operators and, or, and not. There are three fundamental logic gates: NOT gate, AND gate, and OR gate. NOT gate, sometimes called logical inverter gate. To differentiate it from other types of electronic inverter devices, has only one input. It reverses the logic state. The output state is a negation or complement of an input signal. And see the symbol and truth table of NOT gate. Before discussing AND gate, first we can discuss the inputs of gates. In Boolean logic, we studied that 0 and 1 as input or constant of the Boolean. Here in AND gate, we are telling 0 and 1 as false and true. 0 is called false and 1 is called true. AND gate act in the same way as logical AND operator. The output is true when both inputs are true. Otherwise, the output is false. AND gate works on two or more inputs which result in a single output. We can see the symbol and truth table of logic and gate. There is X in symbol. X and Y are input and Z is output. Are you clear? Gate. OR gate acts in the same way as logical OR operator. The OR gate gets its name from the fact that it behaves like logical inclusive OR. The output is true if either or both of the inputs are true. If both inputs are false, then the output is false. OR gate works on two or more inputs which result in a single output. We can see the symbol of OR gate and truth table of OR gate. X and Y are the input symbols, input, and Z is the output. NOR gate. The NOR gate is the combination of OR gate followed by an inverter. Its output is true if the both inputs are false. Otherwise, the output is false. AND gate. NAND gate operates as an AND gate followed by a NOT gate. It acts in the manner of logical operator AND, followed by negation. The output is false if the both inputs are true. Otherwise, the output is true. Next is exclusive OR gate or XOR gate. It acts the same way as the logical either or. The output is true if either but not both of the input is true. The output is false if both the inputs are false or if both the inputs are true. Another way of looking at the circuit is to observe that the output is 1 if the inputs are different, but 0 if the inputs are same. Now we can discuss about how to draw a diagram to the corresponding Boolean expression. Our Boolean expression is f is equal to a dot b complement plus c complement dot d. Dot is the AND operator and plus is the OR operator. Okay, we want to identify the inputs. is output. Here in this Boolean expression we have 4 input A, B, C and D. First we want to complement B and C. For complementing B and C we want to use 2 NOT gates. The B will give as the input of one or NOT gate. Then A dot B complement is the. We want to use AND gate for A and the output of NOT gate B complement. Then next is C complement dot D. For dot we are using AND gate. Then we will complement and use NOT gate for complement. Then use AND gate by input C and D. Then that output we will give to next OR operator. Plus is using for OR operator. Then we will give that to OR operator. Then the output F we will get. So understand that? Have any doubt, you can ask when we come in live. I will discuss that. Next we can discuss about how to write the equivalent logic expression or Boolean expression for the logic circuit. Did you see the logic circuit there? There we have 3 input U, V and W. U is then you give the input as a NOT gate. That will be U complement. Then we directly give to one NOT gate and one OR gate. The OR gate we are using as plus. Then U complement and we give to OR gate. That we can use plus symbol. Then next session V is giving to NOT gate. NOT gate is the output of NOT gate will be V complement. Then W is the W and V complement give to OR gate. That means V complement plus W. The U complement plus V and V complement plus W is giving to the input of AND gate. Then we can write the expression as U complement plus V into V complement plus W. Did you clear that? Computer help us solve problems. However, before a problem can be tackled, we need to understand the problem and the ways to solve it. Irrespective of the language being used, the first and foremost thing while writing a program is to analyze the problem well and try to solve it in a logical manner. The process of writing a program is called programming. We are writing set of instructions to solve a problem involving data processing. These instructions must be executed by the computer to solve the program. Before we start writing a program, the steps for solving the problem should be clear in our mind. Precise, step-by-step instructions should be inputted to the computer system to solve the program. Proper and flawless execution of any task inside a computer depends on how correctly and precisely we define the problem, design a solution, and implement the solution using a programming language. Thus, problem solving is a process of identifying a problem, developing an algorithm for the identified problem, and finally implementing the algorithm to develop a computer program. When problems are straightforward and easy, we can easily find the solution. But a complex problem requires a methodological approach to find the right solution. In other words, we have to apply problem-solving techniques. Problem-solving techniques begin with the precise, identification of the problem and ends with a complex working solution in terms of a program or software. Key steps required for solving a problem using a computer are analyzing a problem, developing an algorithm, coding, testing, and debugging. First step is analyzing a problem. It is important to clearly understand a problem before we begin to find a solution for it. If we are not clear as to which is to be solved, we may end up developing a program which may not solve our purpose. Thus, we need to read and analyze the problem statement carefully in order to list the principal components of the problem and decide the core functionalities that our solution should have. By analyzing a problem, we would be able to figure out what are the inputs that our program should accept and the outputs that it should be produced. This step is developing an algorithm. It is essential to devise a solution before writing a program code for a given problem. The solution is represented in natural language and is called an algorithm. For a given problem, more than one algorithm is possible, and we have to select the most suitable solution. The algorithm is discussed in the successive session. Step is coding. After finalizing the algorithm, we need to convert the algorithm into a format which can be understood by the computer to generate the desired solution. Different high-level programming languages can be used for writing a program. It is equally important to record the details of the coding procedures followed and document the solution. This is helpful when revisiting the program at the later stage. Next step is testing and debugging. The program created should be tested on various parameters. The program should meet the requirements of the user. It must respond within the expected time. It should be generate correct output for all possible input. Software industries follows standardized testing methods like unit and component test, integration testing, system testing, and acceptance testing while developing complex applications. Is to ensure that the software meets all the business and technical requirements and works as expected. The errors or defects found in the testing phases are debugged or rectified, and the program is again tested. Once the software application has been developed, tested, and delivered to the user, still problems in terms of functioning can be come up and need to be resolved for the time to time. We discussed about algorithm in the step 2, developing an algorithm. Now we are going to discuss more about algorithm. Algorithm is the step-by-step process written in natural language. Example, steps required for an activity, ride a car. For that, first step, move the car out of the garage, sit in the driver's seat in the car, start ignition using car's key, press clutches and place the gear in correct position, accelerate and start driving, use brakes whenever need to stop on reaching the destination. The activity ride a car, we write step-by-step process in natural language. In 7 steps, we represent the activity ride a car. Like this, we can represent anything, any activity in step-by-step process. See another example. To write the algorithm to find GCD of two numbers 45 and 54. GCD is the largest number that divides both the given number. For that, first step is find the numbers that divides the given numbers. The divisor of 45 is 1, 3, 5, 9, 15 and 45. Divisors of 54 is 1, 2, 3, 6, 9, 18, 27 and 54. Then find the largest common number from these two lists. Therefore, GCD of 45 and 54 is 9. Now we can discuss about need for algorithm. What is the need of algorithm? A programmer writes a program to instruct the computer to do certain tasks as desired. The computer then follows the steps written in the program code. Therefore, programmer first prepares a roadmap of the program to be written before actually rewriting the code. Without a roadmap, the programmer may not be able to clearly visualize the instructions to be written and may end up developing a program which may not work as expected. Such a roadmap is nothing but the algorithm, which is the building block of a computer program. Purpose of using algorithm is to increase reliability, accuracy, and efficiency of obtaining solutions. Characteristics of a good algorithm: precision, the steps that precisely started or defined; uniqueness, results of each steps are uniquely defined and only depend on the input and result of the preceding step; finiteness, the algorithm always stops after a finite number of steps; input, algorithm receives some input; output, the algorithm produces some output also. While writing algorithm, it is required to clearly identify the input to be taken from the user, processing or computation to be performed to get the desired result, the output desired by the user. Next is flowcharts. Flowcharts are the pictorial representation of a task or algorithm. It is defined as a visual representation of the sequence of steps and decision needed to perform a process or task. They are used to represent how a program works. A flowchart depicts the flow of a program. Charts are used in analyzing, designing, documenting, or managing a process or program. Specific parts of a flowchart represent specific parts of your code. There are mainly 5 symbols used in the flowchart. First symbol is oval shape. It represents start or end point. Next one is arrow. A line is a connector that shows relationship between the representative shapes. Then next is parallelogram. Parallelogram represents input or output. Next one is rectangle. Rectangle represents a process. Next one is diamond shape. A diamond indicates a decision. If there is a question as answer yes or no, it will be represented by decision. We can discuss about the example of flowchart. The question is, draw a flowchart to find average of 3 numbers. First we can use start symbol, that means oval shape. Then we have to input 3 numbers. That input we want to represent in parallelogram. Input A, B and C. Next is process. We want to find the average of A, B and C. That is written in the rectangle. Average equal to A plus B plus C divided by 3. Next is we want to give output. That output is written in the parallelogram as print average. After that, we want to stop the execution. That stop we will write in the oval shape. Did you clear everything? It is an example for another flowchart. Draw a flowchart and write the Python code to get input a name and print hello with name. The flowchart is first we want to start, then input name. Input means it is in parallelogram. Here there is no processing. We getting the input and outputting the name input also. That time we can take another parallelogram and output hello name, then end. Here Python code is the in right side. You can see that first we want to input. Input means name equal to input what is your name. That time the which thing we are typing that will get into the name. Then print hello plus name. Then it will print as hello. Then which name you type in it, it will display the hello with name. Next, we are going to discuss about pseudocode. Pseudocode is used to express our logic independent of any programming language. As the name suggested, it is not a real code. It is an informal approach in English-like language about how we will solve a problem. There are no rules associated with writing a pseudocode. It could be a list of instructions in English-like language or in any programming language. Pseudocode should not be a specific coding language. Draft the structure of your code be understandable to humans. Example, write a pseudocode that reads marks of 10 students and display average of marks. The first step, set total to 0, set mark counter to 1. While mark counter is less than or equal to 10, input the next mark. Add the marks into the total. Set the class average by dividing total by 10. Display the class average. This is the pseudocode for reads the marks of 10 students and display the average of marks. We can discuss another example for pseudocode along with Python code. Your question is to get a name as input and then print this name with hello. The pseudocode is input name, output hello name. The Python code will be name equal to input what is your name, then print hello along with name, that means plus name. Did you understand, children? Computational thinking is the thought processes involved in formulating a problem and expressing its solutions in a way that a man or machine can effectively carry out. So, to write any program, first we have to think computationally about the problem and its solution, and then we have to write the program in a programming language. Computational thinking allows us to take a complex problem, understand what is it, and develop possible solutions. We can then present these solutions in a way that a computer, a human, or both can understand. The process of planning and reaching the goals involves computational thinking of some kind. Computational thinking involves taking a complex problem and breaking it down into a series of small or more manageable problems. Each of these smaller problems can then be looked at individually, considering how similar problems have been solved previously, and focusing only on the important details while ignoring irrelevant information. Next, simple steps or rules to solve each of the smaller problem can be designed. Let us discuss the components of computational thinking in detail. Computational thinking is a technique used to solve problems logically and consists of four key components or pillars described as decomposition, pattern recognition, abstraction, algorithms. Next is pattern recognition. Pattern recognition is the next process in succession that helps in identifying patterns or trends within a problem. Once we have decomposed a complex problem into smaller problems, the next step is to look at similarities they share. We look for patterns when we play games to decide when to do certain things. Based on experience, we develop shortcuts for mapping problem characteristics to arrive at a solution. Next is abstraction. It refers to focusing on important information only, ignoring irrelevant details. To reach a solution, we need to ignore unnecessary characteristics in order to focus on relevant details. It helps us identify specific similarities and difference between similar problems to work towards a solution. So, what is this important information that we need to focus on? In abstraction, the focus is mainly on general characteristics that are common to each element instead of specific details. Common example of abstraction process are a world map is an abstraction of Earth in terms of longitude and latitude, helping us describe the location and geography of a place. A sign of an easel in a store, example Walmart, is an abstraction of the items available in that aisle. Next is algorithm. We have broken down the big problem into smaller, easily manageable problems. We have identified similarities between these problems. We have focused on relevant details and ignored anything irrelevant. Now it is time to develop step-by-step instruction to solve each of the smaller problems, or the rules to follow when solving the problem. These simple steps or rules are used to program a computer to help solve a complex problem in the best possible way. They are also called algorithm. An algorithm is a plan, a set of step-by-step instructions used to solve a problem. Writing an algorithm requires extensive planning for it to work correctly. Next is Python programming language. Python is an open-source, object-oriented, high-level programming language developed by Gui van Rossum in 1991. Presently owned by Python Software Foundation. Python is based on the ABC language, a teaching language creating to replace the programming language BASIC, which was developed earlier. Python is a general-purpose programming language that can be used effectively to build any kind of program that does not require direct access to the computer hardware. Features of Python. Python is an interactive, interpreted language with simple syntax. It has become increasingly popular because of its salient features, which are listed here. Python is interpreted, interactive, directly executed with pre-compiled code. This means that it is processed at runtime by the interpreter and we need not compile the program before executing it. It is a loosely typed object-oriented programming language with few keywords and simple English-like structure, and is easy to learn. It is a free, open source and portable language having a large repository of libraries. It takes less time to develop as Python programs than equivalent Java programs. This is because of it builds in high-level data types and its dynamic typing. It is extendable and extensible and highly efficient, as there is no wastage of time in declaring the types of variable or arguments. It supports GUI, means graphical user interface, and garbage collection. It is easily compatible with other languages like C, C++, Core Java, etc. Python is used for both scientific and non-scientific programs. Advantages of Python. Apart from the above salient features, Python offers the following advantages: platform independent, readability, object-oriented programming language, higher productivity, less learning time, GUI programming, ample availability of libraries, syntax highlighting. Platform independent means it is platform independent and can run across different platforms like Windows, Linux, Mac OS, and other operating systems. Readability. Python programs use clear, simple, concise and English-like instructions that are easy to read and understand when by non-programmers or people with no substantial programming background. Object-oriented programming language. It is an interactive, interpreted or object-oriented programming language. Higher productivity. Since Python is a simple language with small codes and extensive libraries, it offers higher productivity to programmers than languages like C++ and Java. So you write less and get more done. Less learning time. Because of the simple and shorter code, lesser time is required to understand and learn Python program. GUI programming. Python supports graphical user interface applications that can be created and ported to many system calls, libraries, and Windows systems such as Windows MFC, Macintosh, and the X Windows system of Unix. Ample availability of libraries. It provides large standard libraries to solve a task. Syntax highlighting. It allows to distinguish between input, output, and error messages by different color codes. Next is limitation of Python. Apart from several advantages that Python offers which make it one of the most popular programming language, it has a few limitations as well. Speed. It is slower than C or C++. However, Python is high-level language, unlike our C++. It's not closer to hardware. Mobile development. Python is not a very good language for mobile development. It is seen as a weak language for mobile computing. This is the reason very few mobile applications are built in it. Memory consumption. Python is not a good choice for memory-intensive tasks. Due to the flexibility of the data types, Python's memory consumption is also high. Database access. It has limitations with database access as compared to popular technologies like Java database connectivity, Open database connectivity. Python's database access layer is found to be a bit underdeveloped and primitive. It cannot be applied in the enterprises that need smooth interaction of complex legacy data. Next, runtime errors. Python programmers have cited several issues with the designing of the language. Because the language is dynamically typed, it requires more testing and has errors that only show up at runtime. Next topic is Internet of Things. You must have read stories like a person was able to monitor his home through his smartphone even while he himself was sitting in another country. Scientists were able to monitor the progress of whale who was operated upon a chip was inserted in her body. A car sensor alerted the car owner about low air pressure in price in time, and so on. All these are nothing but some example of applications of Internet of Things or IoT. The IoT or Internet of Things is a new age technology that allows computing devices, the devices that can be programmed and can connect to internet, such as smart home appliances like smart refrigerator or smart air conditioner, a smart heart monitor chip, etc., to transfer data over a network like internet without requiring human to human or human to computer interaction. The practical applications of IoT technology can be found in many fields today, such as health and fitness, home security, transport, shopping, smart cities, etc. In health and fitness, IoT smart gadgets that monitor your heart rate, blood pressure, etc., and take action accordingly, such as sending emergency messages or updating daily fitness logo or conducting appointment doctor, etc. That smart gadget examples are Fitbit, Jawbone, Nike, and Misfit. Home security. There are many home safety and security devices for everyone that available. Video surveillance, motion, temperature, and air quality control to help you protect your family and your home when you are not around. Transport. Driverless cars can not only drive or on road without drivers but also can be in touch with servers all time. In shopping, there are smart refrigerators nowadays that can order for grocery items as soon as their quantity in fridge grows below at a set level. Smart cities. The IoT technology is main enabler of making smart cities a reality. Smart surveillance, automated transportation, smart energy management system, water distribution, urban security, and environmental monitoring, etc., are the example of Internet of Things applications for smart cities. I think you understand all things we discussed.